Good evening. The Hubble Space Telescope continues to send back amazing pictures. Just look at this, the Cartwheel Galaxy. Clearly, one galaxy has invaded another, a fantastic cosmic collision. And much nearer home, a picture of the planet Saturn with a new white spot, a glorious view, although at the moment, I'm afraid, we're losing Saturn in the evening twilight. But this evening, I want to stay very much inside our own solar system. Ask most people what is the most distant planet in the Sun's family, and the usual answer is going to be Pluto, discovered way back in 1930 by my old friend Clyde Tombaugh. That picture was taken in 1980, I may say. But at the moment, this is not true. The solar system is divided firmly into two definite parts. We begin with four small solid planets, Mercury, Venus, the Earth, and Mars. Then there's a wide gap in which move thousands of very small bodies, known variously as minor planets or asteroids. And beyond that, we come to the four giants, beginning with Jupiter. And beyond Jupiter, there are three more giants, Saturn, Uranus, and Neptune. And there's also Pluto, which simply does not fit into the general plan at all. To begin with, Pluto is small, smaller than our moon. It goes around the sun in 248 years, and for most of the time, it's further away than Neptune. But at the moment, it's not. Its eccentric orbit brings it inside that of Neptune. And in 1979, Pluto came within Neptune. In 1989, it reached perihelion, it's closest to the sun, and not until 1999 will it again pass beyond Neptune's orbit. Although I may say, Pluto's path is also tilted at the fairly sharp angle of 17 degrees, so there's no danger of a collision on the line. At the moment, anyway, Pluto and Neptune don't go anywhere near each other. But that is by no means the end of the solar system. We believe that much further out, more than a light year being 6 million miles nearly, there's what we call the Oort cloud, named in honor of the Dutch astronomer Jan Oort. And this is believed to be a cloud of icy bodies. Obviously, we can't see them. They are too far away and too faint. But if one of them is perturbed for any reason, it starts to plunge inward toward the sun. And after a journey lasting for hundreds, thousands, or even millions of years, it invades the inner part of the solar system, and we see it as a comet. But in 1992, there was an entirely new development. Over in Hawaii, David Jewett and Jane Liu, using the 2.2-meter telescope there, detected a very different kind of body. It looked like an asteroid. There it is, distinguished by the circle around it. But it was clearly a long way away, and it was something entirely new. They gave it a nickname, Smiley, after a character in a novel, but that name certainly won't be accepted, and at the moment we call 1992 QB1. And since then, more than a dozen similar, very remote objects have been discovered. At this stage, I'm delighted to welcome, once again, Professor Ewan Williams of Queen Mary Westfield College. Welcome back, Ewan.
Nice to be back, Patrick. Nice to see you.
Well, you've been involved in this research from the outset.
Yes, it's a very exciting time to be involved in the discovery of a brand new class of objects in the solar system. I was very lucky to be around when good telescopes became available and good instrumentation. And we had time in September 1993 with Alan Fitzsimmons and Donald Cayley from Queen's University Belfast to search for these objects. We are using the Isaac Newton 2.5-meter telescope, which is situated on the Palmer on top of a nice mountain,
Yes, I know.
which gives us good seeing, good clear skies, and it has a good telescope, the Isaac Newton telescope itself, together with good CCD, large-scale CCD facilities. And using these CCDs, we obtained a series of images, and on a fairly early one, we discovered a slow-moving object. We see it here in the top left-hand corner with a circle around it. In a couple of hours, it had moved, and we see it coincident almost with a sort of fussy, sort of irregular galaxy. And then one day later, it had moved more or less across the image and is seen in the bottom right-hand corner.
That's 1993 SC, isn't it?
That's 1993 SC, yes.
And I understand you found another fainter one.
We also found 1993 SB, which turned out considerably fainter. And if we look at the image of 1993 SB, we can see that it really is a lot fainter. Nevertheless, it does move in the same way, and if we wait for another day, we see it has moved more or less across the image there from left to right.
How did you know that these things were so far away?
You get a clue from the fact that they're moving so very slowly. In the solar system, things close to the sun move fast, things far away move very much slower. But when we look at these objects, we've got to remember that what we're seeing is their motion against the background stars. We're sitting on Earth, we look at the object and we see it against the background stars. The Earth is moving much faster than the object, and if you like, overtakes it on the inside, things you're not allowed to do on the motorway, but the Earth can do it. And the path of the object against the sky then appears to be in a retrograde motion. Now we know how fast the Earth is going, so we can subtract the speed of the Earth from this apparent retrograde motion, get the speed of this thing in orbit. Then if we assume it's a circular orbit, it's a very easy calculation to work out how far away it is.
But how do you know the orbit is circular?
You don't. And for most of these, all we have is a very, very small arc around the time of discovery. You have to assume something to get a distance, and a circle seems as good a guess as any.
Fair enough.
Now, for 1992 QB1, for example, that's now been around for a number of years. We've had observations of it in 1993, also observations of it in 1994. If you stick all those together, then a circular orbit, the blue orbit on this diagram of the solar system, looks quite a reasonable representation. If you assume a circular orbit, you find the object more or less where it is. So it's moving outside Pluto on a near-circular orbit.
Well, so much QB1, but I gather that 1993 SC moves in a very different way.
Yes, 1993 SC, to start with, was somewhat nearer. It moved somewhere between Neptune and Pluto rather than outside Pluto. But more interestingly, even 3 months after discovery, the predicted position and the position according to the circular orbit, again the blue one on the screen, was actually slightly off. As more observations came in, the error between the circular orbit prediction and reality became greater and greater, and it became obvious that one needed a different orbit. Now the trouble is, as soon as you go on an elliptical orbit, not only does aphelion become greater, perihelion, the distance nearer the Sun, becomes smaller, and it gets close to Neptune. And Neptune can disrupt these orbits. So one needed some method of keeping it stable. And Brian Marsden, that's the person who sends out all this information on the IAU telegrams.
Very well too, I may say.
He does a very good job there. But he also has a brain.
Yes,
and he produced a very neat solution for this thing. He suggested that 1993 SC could well be moving in an orbit very similar to that of Pluto. By that I mean that it was an eccentric orbit and the period was 248 years or thereabout, something almost exactly like Pluto. Now Pluto does this very clever trick, and 1993 SC is presumably doing it as well. By that I mean it manages to go round the Sun twice in exactly the same time as Neptune goes round the Sun 3 times. And here we see Neptune has now just completed 1 orbit, Pluto is far away. Neptune is now coming up, has done 2 orbits, and is now rapidly catching up with Pluto, overtakes it, and Neptune has now completed 3, and there Pluto is back in the starting position again. And so this configuration repeats itself time and time again, and we never get close encounters between the body and Neptune, so we have this nice, stable orbit with a period of 250 years.
What we call resonance. What else could you find out about 1993 SC?
Well, by pure luck, or beginner's luck, if you remember, the first image we had of 1993 SC was actually very near the top left of the picture.
Very near the edge, yes.
When you're searching for these things, obviously you don't know it's there, otherwise you wouldn't be searching.
Right.
So you're taking images of different parts of the sky, and of course you want to overlap so you don't miss things on the corner. We took a nice overlap, and we found 1993 SC twice. Being in the middle of the night, you sometimes don't think too clearly, so we thought, we found 2 of these things. So we kept observing both of them. The end result is that we finished up with about 12 observations of 1993 SC, many more than was really required in order to confirm its existence. But that has its advantage, because we were able to work out the brightness of 1993 SC in each and every one of these images, and one could find out whether the brightness changed or not. And we did indeed find that it did. It changed by actually just over a magnitude. We can see very bright, then dims and goes bright again and then down again.